Hi, this is Frank Billau again, and I want to talk to you a little bit more about what I'm doing with streaming data technology, and in particular the IBM Streams product to demonstrate some of its capabilities on my computer. So the example that I'm going to be showing you today starts with temperature and gyroscope data that I'm generating from a small chip, and it's connecting that to the Raspberry Pi. And again, this is data which is streaming all the time. The temperature and gyroscopic data from this device streams all the time across these data ports. In the Raspberry Pi, I'm using a Python program to capture that data and convert it to a TCP stream, that is a stream of data that's being sent out over the network to another computer to the port of the TCP server, which is an IBM Stream server on port 6001. Where it's listening for this data. When the data comes in, I take the data into a TCP data object and break it out into its components. That is, if this is the X, Y, Z, and temperature data, I want to show those as separate components, not just all as one block. And then what I can do is break it out into a temperature stream and a movement stream. And one thing that's really cool in IBM Streams is I can now take each individual stream and I can export that data out of this one application right here into a second application, which does nothing but look for this data as it comes across. And I'm just putting data in files right now. We'll be doing some more interesting things with it later. You can see several places along the way here I actually dump data out into files just so I can look at it and debug it as I go along. But this ability to export data from one application and import it into another is very powerful, because now I can develop my applications independently of each other, and this is all complete, and this is done, this is sort of a finished unit of work, and then I can have either someone else or I can work on this over here separately, knowing that this program right here is all functionally tested and ready to go. So that's a very powerful way of doing application development that fits in well with the way a lot of companies want to have multiple person teams doing development, things like that. So again, we're going to be showing temperature and gyroscope data flowing into the Raspberry Pi, out of the Raspberry Pi across the TCP data port via this Python program, into the stream server, and then once it hits the stream server, I break it apart into temperature and movement data, take the temperature data and export it out to a separate application which is going to import that data and then load it into a file. And like I said, we'll be doing more interesting things with this later. I want to show you some of the devices that I'm working with now really quickly. And what you're looking at right here, this is the temperature and gyroscope device right here, hooked up to a little breadboard and connected up to the Raspberry Pi computer. And I also have a little display output here, which you can see is showing the temperature and time in real time. So if I warm this up over here, what you're going to see here is when this goes above a certain amount, which in my case is when it goes above 70 degrees, and I'm having a hard time getting it to warm up to that right now. There we go. And now it's at 70. One second. Just move this over here and do something a little bit differently. There you go. Now it's at 71, 72. And you notice it's above 70 right now, so it's actually sending that data out over the TCP port. And I take my finger off and it drops back down. So that's showing you what the data is doing, coming, the sort of the real-time data that's being generated. And like I said, the minute it drops below 70, it sort of stops. And if it goes back above 70, it's going to keep sending out data. What's happening in Streams, though, is you can take a look at, these are all those objects that I showed you over there of all the different things that are going on with it. And again, I'm going to put my finger over it, and as it starts sending out data, it is actually now sending out data over, and you see these things changing color basically as data is moving through them. And again, this is data that's moving in real time. And I'm going to put this back up here. So what you're looking at is, again, the temperature and the gyroscope data. When it goes above 70, the Python program here says send that data out over the TCP port. And the TCP port is picking that up in the stream server and transferring the data into a file at the end, which says this is only the temperature data which went above 70. And if I look at the data, the files that this goes into on the server here, you will see that there's just the data which is above 70 degrees in that file. So this is very useful, because if you're processing lots and lots of information, say millions of records per second, stuff like that, you don't want to look at all of the data. You want to apply filters along the way. You want to look at what's interesting and be able to do things to that data in real time. And so this tool allows you to take this generated data of any kind, and this could be telephone data, this can be image data, this can be anything. It's just an example of a data source. And this allows you to look at this data, process it, and flow it through in real time. And this is the essence of streaming data. This is what makes it so powerful, is that you can actually do this without stopping the data. I don't have to store all this data. I can only pull off the data that I'm interested in and store it and work with it. And we're going to be doing some more things later with the data that we take off out here and we put it into these files. And we're going to show you some stuff moving that to technologies like Hadoop, moving it into relational databases, and doing further analysis on data that we've gathered off of real-time streaming devices. And it should be pretty exciting. So I look forward to showing you more later. Thank you.